To predict what's likely to happen to the Earth's climate in the future, climate scientists build detailed computer simulations. These consist of a collection of mathematical models covering all possible influences on the results. Accurate recreations of how the atmosphere and oceans behave are also included. The models interact with each other, just as the Earth's natural systems would in reality. They work by calculating snapshots of the climate, taking over regular time periods, progressing into the future, typically at half-hour intervals. The calculations are performed for every location on a 3D grid covering the whole planet. They require a huge amount of computer power because every grid point is affected slightly by every other one, making the calculations far slower. For simulations to give accurate projections, the scientists must include estimates for external factors, such as how much greenhouse gas we'll emit over time. This is impossible to predict accurately for the long term, so separate simulations are run to cover a range of future possibilities. Just as improvements in computer power over the years have led to more realistic, high-resolution video games, the same is true for climate models, which push the fastest supercomputers available to the limit. Current simulations often have grid points around 100 kilometers apart. Halving that distance would require a 10-fold increase in computer power, but the current resolution is still good enough to represent large-scale weather systems. Current weather forecasts can use resolutions of only a few kilometers or less, but they only need to predict the results for a few days ahead, rather than the decades required to predict the future climate. But how can these long-term climate projections be accurate when forecasting the weather for only a few weeks ahead is a challenge? Weather is highly complex and unstable, but this behavior tends to balance itself out over time, which allows climate models to give accurate long-term trends, even if they can't predict the specific details. For all their sophistication, how do we know these climate models actually work? Scientists often check their models by comparing calculations for the past century with the equivalent observed results. If the two are close, then scientists can be more confident that the model is reliable. What about the results of old climate models published in the past? How successful were these at predicting the climate we have now? Let's overlay some old results onto our observed global temperature data and take a look. The early models were very primitive by modern standards, but they became increasingly sophisticated as computer technology improved. The projections that you can explore in Climate Station are based on combined results from multiple climate institutions, published in the latest report from the Intergovernmental Panel on Climate Change. They convey the best estimates that we currently have on what our future climate will likely be.